This is the second video in the set of solutions for the Module 1 practice test. We're looking at question 3 now. A carpenter has two boards. The first is 13.5 feet long, and the second is 1/3 the length of the first. We want to figure out how long is the second board. We'll calculate our answer and report it as a mixed number. Our first board is 13.5 feet. To figure out 1/3 of that, we multiply by 1/3. Before we can do this multiplication, we need to convert 13.5 to a mixed number. So I take the whole number 13 and multiply by the denominator 2. And then I add the numerator 1. That gives me a new numerator of 27. So 27 over 2 is the same as 13.5, and I'm still multiplying by 1/3. I can go ahead and do the multiplication here, multiplying the numerators together and the denominators together, or I could recognize that I have a common factor and cancel out and reduce here. 3 goes into 3 once and into 27 9 times. Then I can continue on with the multiplication. 9 times 1 is 9 over 2 times 1 is 2. Changing that back to a mixed number, 9 divided by 2 goes 4 whole times with a remainder of 1, and that stays over the denominator 2. I need units here. My original units were feet, so the second board is 4.5 feet long. You could also use your calculator and the fraction key for this, and should get to the same answer, 4.5 feet. In the next question, we'll deal with some decimals. To install ductwork in a house, a technician has measured different lengths that are required. The measured lengths are 6.167 feet, 4.667 feet, 3.833 feet, and 12.5 feet. I'd like to know the total amount of ductwork required, so I need to add these values. You could do it by hand, or you can use your calculator. Once you add them up, you get a total of 27.167 feet. However, we need to pay attention. These are measured values, so we need to consider again the accuracy and precision of our measurements and what we can report in our answer. Our operation here is addition, so we need to consider the precision in our final answer, which means we're looking at our least precise measurement, which is here. 12.5 is only measured to the nearest 1/10 of a foot. I need to round my final answer the same way, so I'm going to round it to the nearest 1/10 of a foot. I look one digit to the right is a 6, so I'm going to round up to 27.2 feet. So when we're dealing with measured numbers in these units, we've been talking about accuracy and precision, and we need to remember to round our final answers appropriately. As a review of significant digits, we can complete this table below. In the table, I'd like you to just indicate the number of significant digits for each of the measurements, remembering that significant digits are simply measured digits. So we know any non-zero must be significant, and then the zeros we need to look at and decide if they were measured or if they're just placeholders. So in our first value, 3.00 pounds. We know for sure the 3 is significant, and these zeros written after the decimal, after a non-zero digit, are significant. They're written there to show that we measured to 2 decimal places. So this has 3 significant digits. In 12.01 ounces, this 0 is sandwiched between non-zero digits, so it must have been measured. So this is 4 significant digits. In 300 centimeters, I don't have a decimal place, so I don't know that these zeros were measured or if they're just placeholders. So this is only 1 significant digit. These zeros are called trailing zeros. And in the final example, 0.004 kilograms, these zeros before that first non-zero measured digit are called leading zeros, and they are not significant. So this is also 1 significant figure. You'll need to be able to figure out the number of significant digits in measurements, especially when it comes to rounding your unit conversions in the next bit of the test. If you need the solutions for the next questions, be sure to check out the next video.